All right, we're going to look at a few delta math exercises with antiderivatives. The first one is a time challenge. So I want you to become really fluent at the power rule of antiderivatives. So there's really two rules that you should do. So one is add 1 to the exponent. And 2 is divide the coefficient by your new exponent. So with that in mind, let's actually take a look at these and kind of build some fluency. So we want to do these in, a certain number of seconds. So the first few times that you're doing antiderivatives, you may want to take it a little bit slow, and that's okay. We do eventually want you to meet the time challenge. So I would do this, what I would do first is I would add to your exponent 1, and I would actually take your coefficient and divide by your new exponent. Don't forget the plus c, so you would actually have, in this case, -1/2, and then x to the -2 plus c, and you choose that answer choice. And then as you kind of get going a little bit more, then you can kind of look at some patterns and try to get some more speed. So in this case, actually, I can look at some answer choices and see that we could eliminate any of these x to the third ones. But it's asking for the derivative in this case, so I guess we do want to, does mix in a few antiderivatives and derivatives. So actually, the x to the fifths we want to eliminate. So we just want to find the derivative. This is just like the good old days. All right, then this one, we can kind of eliminate the x to the thirds. So we're looking at the x to the fifths. And actually, if I tried to take the derivative, this would be 5x to the fourth. But then this one would be 4x to the fourth. So you really want to kind of just internalize the basic power rule of adding 1 to the exponent for the antiderivative and dividing the coefficient by your new exponent. All right, the first type of exercise that you'll be working on are the level 1s. So this is just taking your basic antiderivative rules. One thing to kind of note here, and we'll call this example 1, is that if I take the antiderivative of a constant, that I just add an x to it. So if I took the antiderivative of 3, this would be 3x plus c. Or if I took the antiderivative of 7, this would be 7x plus c. So when I'm doing this, I'm going to actually take the antiderivative here. So this is going to be 2x. And I'm going to add 1 to the exponent. And I'm just going to do this nice and slow at the beginning. So I have 3 plus 1. And then my coefficient was 1 over 3 plus 1. So this is going to be 2x plus 1/4 x to the fourth. And then make sure that you're adding the plus c in as well. So this would be 2x plus 1/4 x to the fourth. And then we'll add a plus c in there as well. And then we are good after that. A way that you could actually check before you even turn this in on delta math is actually just take the derivative. Now, what I will say is, do you need to have so many intermediate steps? if you are really getting the rules down very, very well, you could actually pretty much get from here to here very quickly. And that's actually a good sign because that's showing us that you know your rule very, very well. All right, here's a level 2. Now, level 2 just adds a little bit more algebra that you have to do first. Actually, we are going to learn a shortcut as we get a little bit more into this antiderivative integral unit. But right now, we're just going to kind of use some old school algebra. It's very important to keep the integral antiderivative sign in until you have actually taken the antiderivative. So one of the biggest mistakes that people make is they may do things to simplify what is inside the integral sign. And that's actually, not a very good idea because we need to keep track of whether we have taken the antiderivative or not. So when we do this, I get 4 times 4, so that's going to be 16x to the 4th. And then let's see, I got 4x squared plus 4x squared, so I got an 8x squared, and then I have a plus 1. And I'm then going to take the antiderivative. So for this, I get x to the 5th. And remember that you want to put this over your new exponent. And then this would be 8/3 x to the 3rd plus x plus c. And we'll just actually write the answer out. So I got 16/5. And then want to push the arrow key to get the stuff out of the fraction. And then if you do the caret key, it will get that exponent in nicely. And then we're good. And one more exercise that will kind of show you is what happens when we have radicals and stuff as well. All right, just like power rules, we also have radicals to kind of make things a little bit more interesting with anti-differentiation. This is example 3. So with these, you want to write as fractional exponents first. We like to give you some practice with those fractional exponents so your differentiation and anti-differentiation skills procedurally are very good. So what I would do kind of immediately here, I would not anti-differentiate until you have the nice like a x to the exponent type of form. So this is going to be x to the 3/2 dx. And then I'm going to take the antiderivative. So this is going to be x to the 3/2 plus 2/2. So that's just adding 1. And then in the denominator, I have 5 over 3/2 plus 2/2. And you don't have to do this step if the rules are coming naturally to you. So our new exponent would be x to the 5/2. And then let's see, we have 5 over 5/2. And 5/5, well, if you kind of think about like 5/2.5, just make sure you're adding your plus c as well. This would come out to 2 x to the 5/2 plus c. And I think they do like it in radical form. So we can just write this in radical form, and then we'll be good. So this will be 2, and then the square root of x to the 5th plus c. And we'll just take that radical out. And then we're good. Actually, I think you could even just keep it in fractional exponents as well. If you kind of want to see the number sense of how they got to the 2, one of the things that's kind of going on number sensically here with each step. So like if we have 5/5, this is the same thing as 5 times 2/5. And then that just gets us a +2. So if you can do the radical ones, then you have been very well set at being able to do the power rule.